make them visible before the class. It was just an oversight on my part. So if you ever go to find the lecture slides before the class and they're not there, please let me know, because it's not intentional. Okay. Because I've still got people joining the class, and the makeup of the class is changing every week because we're getting people transferring into different courses and people transferring into this one. Again, I'm passing around the sign-up sheet. If you're not on the list, just add your name down the bottom. And if you don't have access to the mole area, you put a little star next to your name so that I can add you on. Okay? I think I just went through the list of people on mole before this class, and I think that everybody, and sorry, it's put it in its default sorting order. I didn't change it, so it's sorted by your first name rather than by your surname. Sorry. I did check all of the mole area before I came, all the users who were on it, and I think everyone who's on that list now has an account, access to the area on mole. But if you don't, let me know. Okay, so last week we focused on agile software development, and as I intimated in that one, that's kind of like the preferred way that I would like you to go about it when you do your software project in second semester. In that particular time, you're going to be working to develop something very quickly because you've only got 12 weeks a semester. And I will represent the client. Okay, we have a real client, but they're down in Cambridge, so it's a bit hard to organise meetings with them, but I've worked with them, so I know what their needs are and that sort of thing. So we'll do that at that point. You'll be working in teams. I'll have you split, I think, into 3 separate teams. So you will all, each team will do the same thing. In a sense, you'll be competing to provide the best solution for the client. Okay, and you might interpret the client's needs slightly differently or something like that. Okay, so we do this for our second year undergraduates, a similar type of project. And typically what we see there is that they do have very different solutions to the same problem. Right? So anyway, but that, yeah, agile development is suitable for rapidly changing, quickly developing interactions where you have close contact with the client or a representative of the client. In this case it's going to be me. And it's being increasingly used in industry these days. But traditional software engineering processes, which we talked briefly about in the first lecture, are still very much part of the sort of standard practice in older software companies, and particularly big multinational type ones where they're working on very large projects. We discussed last week a bit why Agile doesn't really work that well with very large projects, but you can embed some Agile practices into subparts of large projects. And in fact, IBM is one big multinational company which very explicitly uses Agile practices in the scope of more structured software engineering processes. Okay. But in this lecture, we're going to look at requirements engineering, focusing on the more traditional type approaches to requirements engineering. And I'll talk a bit as we go along about how it differs from agile approaches to requirements engineering. So, we're going to talk about all these different subtopics, functional and non-functional requirements, the different types of requirements engineering processes that you can have, and then 4 sort of subcomponents of requirement engineering, which include elicitation, specification, validation, and managing change. Right? So, starting off with what is a requirement for the benefit of the people who are new today. I think there's a couple of you. Any slide like this is one that comes with the textbook. It's sort of paired with the textbook, prepared by the author of the textbook. He's another British academic at a Scottish university, I think, in Somerville. And yeah, so basically These are his words rather than mine. Although, whenever I use the slides, it's because I can't say it better than he does. I will say it this way anyway. So essentially, a requirement is some way of representing what the user needs, right? And it can be anything, the way that it's presented, it can be anything from a high-level abstract statement through to a very detailed mathematical specification of what they need. And requirements can serve two purposes. It can be the basis of a bid for a contract, and it can be the basis of the contract itself. Okay, if it's a bid for a contract, then you don't want to tie yourself down too much detail, because the way that you interpret what the client needs might not exactly match what they actually think they need. Because typically when you're preparing a bid, you don't know all the details. You haven't had much chance to interact with the customer, that sort of thing. But when it's the basis of the contract itself, you do want to be quite specific and tied down in detail, because it's a statement of exactly what you've promised to deliver, and you'll get sued if you don't deliver what you say what you've promised. And so you need to be quite precise and make sure there's no room for ambiguity. Okay, if you write something ambiguously and you deliver what you think satisfies that requirement, but the customer actually interpreted those words quite differently, they'll have a case for taking you to court if you don't deliver what they thought they were going to get. Okay, they wouldn't necessarily win, but still you don't want court cases, right? So either of these things can be called requirements, whether you're sort of specifying it because you want to win a bid, or you're specifying it because you actually want to build a contract about the software that you're going to deliver. On top of that, there are two different types of requirements. We have the user requirements, so they're like the things that the user wants to do with the system, and then the system requirements, which are more sort of low-level type things. Okay, so about the system's functions and the operational constraints. So a couple of examples to illustrate it. These are taken from the textbook. This Mentacare system is an example that runs throughout the textbook. Okay, so if you've been reading the textbook, you'll be familiar with it already. So one example of a user requirements definition would be the Mentacare system shall generate monthly management reports showing the cost of drugs prescribed by each clinic during that month. So there are some users of the system who have this as a requirement, right? Presumably the administrators who are managing costs. In terms of the systems requirement, there's this whole series that are related to that user requirement. So we have, on the last working day of each month, a summary of the drugs prescribed, their cost in prescribing clinics shall be generated. The system shall generate the report for printing after 17:30 on the last day of the month. Report shall be created for each clinic and shall list the individual drug names, number of that, and so on. So this is, if you like, this one's a bit more imprecise, the user requirement, right? And then the system requirement is sort of all the details of what the system's going to do in order to support that user requirement. Okay? Now, it doesn't have to do it. You wouldn't have to satisfy that user requirement with this particular set of system requirements. Okay? But if it's in the design document, the requirement specification, then that is the way that you're going to do it. It's kind of like the contract. Okay? You don't always spell things out in such detail in your requirement specification. if you do it this way, and then the user turns around later and says that actually they want to do it some completely different way, it's a basis of a contract negotiation change, basically. So it's a bit more setting in stone exactly how you're going to do it. And it can make life easier for you if you've thought it through properly. Okay? Okay, so in order to gather your requirements, you need to consider your stakeholders. And basically, a stakeholder is any person or organisation affected by the system in some way, so who has a legitimate interest. And stakeholder types vary quite considerably. You have the end users, obviously. Right? They're going to be your primary stakeholder, the people who are actually going to be using your system when it's operational. You've also got the system managers, the system owners, who might be the same thing as the managers, but not necessarily. And then you have external stakeholders. Who can give me an example of an external stakeholder?
Maybe authority.
Yep. So take that Mentacare system before. It was to do with prescribing drugs and that sort of thing. So if it was tied into the NHS health system, you would have government departments who were external stakeholders who would be interested in the way that that system is being used and how efficient the country is about its, treatment of different diseases and that sort of thing. Okay? You might have research organisations who are interested in it as well. Okay? Particularly if you've got drugs that are being used on a trial basis. Regulatory bodies are typical types of ones you'd have. Right? So any number of external stakeholders can be involved. Okay, now I've said we'd talk a bit about agile methods and requirements. So agile methods argue that producing lots of detailed documentation is a waste of time because your requirements change so quickly. And as a consequence, you write a formal requirements document, it's always going to be out of date because you're changing your requirements, or updating your requirements basically every time you see your customer. You're usually having incremental changes, right? And typically what you do in that case is you represent your requirements in terms of user stories. Okay? And for business systems, like if you're doing something that's like a database-backed website or something like that, it's quite a reasonable approach. It has its issues, particularly in terms of contractual agreements, as we talked about last week. But when you're dealing with critical systems, and safety critical systems particularly, or systems that are spread across several different teams, where you have sort of over-diverse sites or something like that, it's really difficult to keep that big picture where you've got diverse locations of people. And it's also, even if it's just large numbers of people, remember we talked about agile methods basically being suitable for teams of 10 people or less, where you're all co-located, you talk to each other on a daily basis, as a matter of fact, and it relies upon that constant communication type thing. With safety critical systems, you're obviously got very, very precise specifications that you have to meet. Okay? There might be some aspects of it which are more open to interpretation, but when you've got an aircraft that has to stay in the air, it's got to stay in the air. And it's not just that it's got to stay in the air, there's a whole bunch of underlying software that has very, very precise safety restrictions about the way that it's used. And it's not just aircraft that have these things, medical software for medical systems, any number of things where you don't want to lose those very important safety critical criteria. Okay? So, what happens in those, particularly for safety critical systems, is you'd say agile methods are essentially not appropriate. Or you might sort of box off one section of the system where it's appropriate to manage it with an agile approach, but have a large portion of the system which isn't. That's a risky approach because obviously, you know, even if you sort of identify, say, the user interface as something where you could do it with an agile approach, there's still safety issues compared with the user interface. So you need to be able to ensure that when there is a system problem in one part of the system, that the person using the user interface gets notified of that. And that's a safety feature. So it's very hard to box off a part that doesn't interact with the safety critical features of a system. Okay, so functional requirements. Functional requirements are basically statements of services that the system has to provide. How the system's going to react to particular inputs, how the system should behave in particular situations. In some cases, it will also say what the system should not do. Okay, so if there are particular things that you don't want to happen very explicitly, you can state them there as well as a functional requirement. Okay, so essentially they describe functionality. And they depend very much on the type of software and the expected users of the system and the type of system where the software is being used. Okay, so if you're designing a system that is going to be used by administrators in a large organization, those administrators probably have fairly defined roles and quite, you know, they know exactly what they want to use with the system. If you're designing a piece of software that's going to be used out in the wild, say the software behind the self-service checkouts at the supermarket, you have an incredibly large user base there. It's not just the people using the scanners, but it's also the administrators behind who are making sure that they're working properly and that you're gathering all the data about the inventory of the supermarket as things get bought and, you know, all that type of thing. So you've got a hugely diverse user base. And your requirements, your functional requirements, are going to look quite different for that type of system to one where you've got a very small, precise set of users. Okay. You're going to have a lot more functional requirements as well, but it's not just the volume, it's the type. Okay, so they could be just high-level statements of what the system should do. A bit like the user stories that we were talking about when we were talking about agile methods. And they should, just like getting a complete set of user stories, cover